Hey everybody, and welcome to this video on solving equations with the variables on both sides. So let's make it happen. All right, consider an expression like 5d plus 4 plus 2d. Now, how could we maybe make this simpler? Now, if we ever have two terms, each having the same variable, and the variable is raised to the same power, then those two terms are called like terms. And we can combine these like terms by simply adding their coefficients. So for instance, 5d and 2d, we could add those together and call that 7d. And we end up with 7d plus 4. Recall, 5d means d plus d plus d plus d plus d, and 2d means d plus d. So it's no surprise that when we have something like 5d plus 2d, we end up with 7d, and in this case, 7d plus 4. Let's try a few more. How about negative 3m minus 4 plus m? Well, I see that these two terms both have m raised to the first power, so negative 3m plus m should equal negative 2m, and we should end up with negative 2m minus 4. Now, if you want a quick reason as to why that's the case, negative 3m is the same as saying negative m plus m plus m. And if we distribute this negative sign to all three of the m's, we get negative m minus m minus m. And of course, if we have these three negative m's and we add 1 to that, we end up with our final result, negative 2m minus 4. One more example together before you try some on your own. Negative 5 minus 3d plus 12 minus 5d. In this case, we have one pair of terms, each having d raised to the first power, so that's going to give us negative 8d. And then we have two numbers, negative 5 and 12. And we can add negative 5 and 12, and we end up with 7. And so this expression simplifies to negative 8d plus 7. Why don't you take a second to simplify these next two expressions by doing what we've been doing, which is called collecting like terms. All right, I hope that went well for you because this is going to be a big skill in this section right now. All right, consider the equation 5m plus 6 equals 2m plus 12. Now this is very different from any equation that we've seen before. Now, our eventual goal is to take as many steps as we need to transform this equation into one in which we have just a number on one side of the equation and then a whole bunch of m's on the other. And if we can get to that point, we'll be home free. Of course, we could do vice versa and have just a number on this side of the equation and a whole bunch of m's here. But the long and short of it is we want to have a bunch of m's on one side of the equation and just a number on the other, and then all we'll need to do is multiply or divide, and we'll isolate that m and solve the equation. So how are we going to do that? Remember, the only things we can do are add or subtract the same number to both sides of the equation, or we can multiply or divide both sides of the equation by the same number. Okay. So what I'm going to do is I'm going to try to collect all of our m's on the left side and all of our numbers on the right side. Let's start by subtracting 6 from both sides of the equation. Not so bad. Now we've got the equation 5m equals 2m plus 6. Now here's my claim. We don't know what m is. It represents a number, but we don't know what that number is. So we don't know what 2m is. But 2m is a number, which means we can, in theory, subtract 2m from the right side of the equation and 2m from the left side of the equation. It's the exact same number. We're subtracting it from both sides of the equation. This is a legal move. And 2m minus 2m, that's going to be 0. And 5m minus 2m, we just discussed, is going to be 3m, and we end up with the equation 3m equals 6. No problem at all to solve that. All we need to do is divide both sides of the equation by 3, and we end up with our solution, m equals 2. Let's take a second to check that solution and make sure it actually works. Awesome. So if m is equal to 2, then both the left and right hand side of our original equation are 16, and so 2 is the solution to that equation. All right, consider the equation negative 2w plus 7 equals negative 5w minus 14. Now, there are a lot of different ways to go about solving this equation, but as long as we use our properties of equality properly, we'll be fine. For the first equation, let's try to collect all of our m's on the left-hand side of the equation and all of our constant numbers on the right-hand side of the equation. I think we should begin by adding 5w to both sides. Of course, we don't know what w is, we don't know what 5w is, but it is a number, so as long as we add that same 5w to both sides, that's an okay thing to do. And now we're left with an equation just like the ones we discussed very recently. This is going to take 2 steps, but it should be no sweat. First, let's subtract 7 from both sides to isolate that 3w. Now let's divide by 3 and we'll isolate w and find our solution. Now, we kind of arbitrarily decided to collect all of our w's on the left-hand side of the equation and all of our numbers on the right. There's no reason we couldn't have done it the other way around. So here, let's try collecting all of our w's on the right and all our numbers on the left. Let's start by adding 2w to both sides of the equation. Again, we don't know what w is, we don't know what 2w is, but that is a number. So if we add the same number, 2w to both sides of this equation, that's totally legit. And again, we're left with a 2-step equation. This will be no problem for us. Let's start by adding 14 to both sides of it. And now let's divide both sides of this equation by negative 3. So both times we found that the value of w was negative 7. Let's quickly check just to make sure. Awesome! So our potential solution checks, and we find that when the value of w is negative 7, both sides of this original equation are equal to 21, so negative 7 is our solution. Alright, here's another, and immediately we can tell this one's going to be a doozy. First things first, what I would do is I see that we've got some cases where we're going to need to use the distributive property, and I would do that first. I would multiply out this 4 times the quantity of d minus 2, and this negative 5 times the quantity of d plus 2. Then it's probably best to collect like terms on either side of the equation before doing anything else. Woo! Now we got something that looks at least a little bit more familiar. Again, we want to collect all of our d's, all of our variables on one side of the equation, and all of our constants, all of the just numbers on the other side. Doesn't matter which side, I'm going to collect my d's on the left by adding 4d to both sides of this equation. At this point, we should be good to go. And so we find our solution to be d equals 3/10. Now that took a lot of steps, but that's how it's going to be sometimes. And remember, we're showing all of our work and writing each new line directly below the line before it. Alright, time for some practice problems. We got 3 equations right in front of you. Why don't you pause the video, please solve these 3 equations, and when you're done, play the video and we'll check your work. Alright, now what if we have all sorts of nasty fractions in our equations, like these 2 right in front of us? So, if we have an equation with lots of nasty fractions in it, it's probably best to clear those fractions before proceeding with anything else. And remember, to clear fractions from an equation, all you have to do is find the lowest common multiple of all of those denominators, and if you multiply both sides of the equation by that, you won't have any more fractions and only integers. So for instance, in our first example, I see a denominator of 3, 4, and 6. Their least common multiple is 12. Let's go ahead and multiply both sides of this equation by 12. And now we're left with an equation that, while not super easy, doesn't have any fractions at least. So why don't you go ahead and finish this one up? All right, not so bad. Kind of ran out of space there a little bit, but hey, we made it work. And we find our solution to be -4. All right, we got one more toughie down below. Why don't you pause the video, clear those fractions, solve the equation, and then play the video, and we'll see how it went. All right, just two more. Let's start with just the first equation. Why don't you go ahead and pause the video and try to solve this one. And when you're done, play the video and we'll see how it went. Very interesting. So as we made our way through solving this equation, we ended up with a nonsensical statement, 5 equals 7. Well, what does that mean? What it means is, if this original equation were true, then this statement must be true. And then this statement must be true. But 5 equals 7 is not true. There's no value of a that's ever going to make this true, so there's no value of a that'll ever make this true. And therefore we'd say that this equation has no solutions. And in general, if we're ever in the process of solving an equation and we end up with an obviously false statement, for example, 5 equals 7, then our equation will have no solutions. All right, let's try the second one. Once again, why don't you pause the video, try and solve it, and when you're done, we'll see how it went. Whoa, whoa, whoa. As we made our way through solving this equation, we ended up with an obviously true statement. 0 equals 0. I mean, before we got another obviously true statement. 6 equals 6. Well, what does that mean? Well, for our original equation to be true, then it also must be true that this is true, and that this is true, and that this is true. But 0 is always equal to 0. What does that mean? It means that every value of a that you could possibly think of will make this original equation true. Try it out. Pick a random number, substitute it in, and you'll see that the two sides of that equation are equal. So what does that mean? It means that this equation has infinitely many solutions. And in general, if we're ever trying to solve an equation and we end up with an obviously true statement, then we know that our equation has infinitely many solutions. All right, guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.